Next, we'll have Michael Hoehn. Did I pronounce that right? Hoehn. Michael Hoehn, Senior Computational Designer at Buro Happold. We have Chris Connock. Did I get that right? All right. Principal Design Computation Director at Kieran Timberlake, and Heath May, Principal and Director of Line at HKS. So with that being said, George.
All right, thanks, Charlie. Okay, so I spent 20 years in the industry. I'm not going to go into the whole thing, but I do feel the pain. I left the industry to basically try to do what we're doing here. This is a really big topic. 20 minutes is not enough time for me to go through this, so we're going to speed through as best I can and then just questions later, okay? So I try to tailor this to what I can in 20 minutes that'll hopefully make sense to everybody for those that don't know about this. I got to put our little safe harbor up here because I show things that aren't quite out yet or in development. Okay, so why Omniverse? Super big question. I'm hoping I can tell the story as we go through here, but I think this picture says a lot, and we'll see more as we go through. But the biggest reason is we develop this actually internally for ourselves. We collaborate amongst a lot of teams at NVIDIA. So a lot of people think that we do hardware, which we do, those are GPUs, but we have a lot more software engineers than we do hardware. And so we share between a lot of the different resources, and we're taking data together, right? I don't need to speak to the slide, you guys know all this, but this was the reason we created it for ourselves. As we were developing it, we realized that it could actually go out into the world. So that's part of the reason. And then the other reason is, as we've been talking to a lot of people, is we realize that this can actually help all the industries, right? So today we're here about our industry, but it's also applicable to M&E, games, product design, manufacturing, scientific biz, robotics, and autonomous driving. And parts of these actually all cross each other in some fashion, depending on what project. So what is Omniverse? I'm going to show a video. This is by the creative team, so this was not done by me. It's super cool. But the reason I want to show this is it shows the breadth of what Omniverse can do. Again, we're here about us, but there's facets that kind of do other things, and that's the really hard story to tell. So, do we have audio? Not that we need it, but it is there. Okay, we'll go without the audio. So basically what's going through here is it's talking about a lot of different things that live inside of Omniverse that, again, it's a platform. There's a lot of pieces to it. So, there was basically a lot of different things, but we're showing kind of, tornado simulation, right? So this was done by somebody at the University of Wisconsin, particle simulation, physics, right, from our flow piece. Omnigraph, we're doing things with physics, right? So that's also, I'll get into open sourceness that we have with physics. Action graph is something we have in here to make things easier to go through. This is actually from BMW, so they're using Omniverse. Machine learning for physics simulation. It goes through a lot of this with the manufacturing side on the robots, right? Training them to how to do things. Not quite our industry, but I have people ask about audio to face. Interior spaces, you can see this was, again, not done by my team. This is the creative team, so they do a phenomenal job. More simulation, right? Character simulation. And the key that you're seeing this is, as robotics and other things go up through here, it's a simulation platform, first and foremost. The pretty visuals are there, but it really is about simulating the data. So drive sim, we do a lot of things with autonomous driving. And this is a big thing that actually is done by our CEO. He wants to create a full replica of Earth 2, as he calls it. So the idea is to simulate the world, and when it's done, you would be able to plop a building anywhere in Earth 2 to see what happens in that part of the world. Okay, so I'm going to take you on a little story as to how all this kind of happened. And the first part of that story is something called universal scene description. So USD is the foundation layer of how Omniverse works. So this was invented by Pixar over a decade ago. Again, for similar reasons, they were using a lot of different apps and having problems sharing data from one app to the other. So they came up with USD, and then in 2016, they open sourced it. Okay, so first and foremost, this is open sourced. Pixar maintains the main branch. We collaborate with them. Apple collaborates with them. Anybody that has an iOS device, to give you an idea, your little emojis are a flavor of USD. Okay, USD is great because, as it says up here, it's non-destructive. We don't do any decimating. We take full fidelity of any geometry, and it takes holistic data. So we're talking metadata, all sort of data that can come in. Okay. We're going to come back to USD in a second. I'll kind of step through. The other thing that's open sourced is our material definition language, so our MDL library. This is a really big thing because the materials that we do are photo accurate, right? They're true representation of what's there. So when light bounces off of it, how does it reflect in what happens to it? So these are all physically accurate materials. And it's also the underlying foundation of saying, okay, when I bring data in, I'm using one standard set of materials to build things. And then if we go back to USD here. So basically because it's open and free, it's excellent representation for, again, holistic data. Okay, you can do anything with it. As you can see here, basically what we've done is kind of an ecosystem that supports. So we've written some connectors that kind of take out the data from Rhino, Revit, ArchiCAD, whatever it is, and convert it to USD, and we've had other companies create their own. So the other key piece to this is the ecosystem is extending just beyond us, you know, as a whole, Apple and Pixar itself. So it's not owned by one company, like I said. The schemas are constantly kind of being developed, right? So we have a lot of people that are coming up with new ways to connect data. That's the key. It doesn't mean that you necessarily have to convert the data to USD. You could stream data through USD to bring it into us. But the underlying foundation is people are starting to see we can kind of have a file format, if you will, right? And it's not specific to just our industry. It goes to a bigger ecosystem. Now, the thing we're going to get a little kind of inception here as to how we work as we go through this, but you can work in a couple different ways with USD and something we have that we created to make Omniverse special. So you can work as a singular person on your machine, you know, could be virtual, could be physical, as a solo workflow that can easily go between the apps. You're not exporting, you're not importing, you can actually be in a live sync mode. Then we can also do enhanced workflows, right? So you could be sitting next to each other, or you could be like most of us working from home now, where you're in two different parts of the country or completely different countries, and you can actually be collaborating in real time. So somebody could be in Rhino, somebody else could be in Revit, somebody could be in Max, somebody could be in Omniverse. You can actually talk to one another in real time with the data. So as one person changes data, depending on where the source data is coming from, it either pushes data in or there's a bidirectional piece. Okay, so there's a little bit of a difference between the connectors, but you can literally see the change in real time, and I'll show some examples of that. The key piece is these are some new slides. So we wanted to try to help people understand what you can do with Omniverse. So in this, you know, we can enhance workflows. We can talk, like I said, different offices. You could do disciplines, locations, countries. Think of how we work with consultants, and we usually share data, but it's like a wall. You can still actually create that wall, but if the consultant is actually using this, their data can be updated to your main model in real time. So you could kind of have separate servers that are talking to one another, but the consultant doesn't have to see the whole picture, or they can see the whole picture. So there's a lot of different ways to look at this. And then it's not just about coming into us or a singular file. That's the great thing. So USD can enhance collaboration on a lot of different levels. So you can collaborate on a singular massive shared file, or you can collaborate on many multiple files. So imagine you had a team of 15. Each of those 15 people have their own files. And then at the end, you kind of combine that into a singular world. But those individual files are always feeding that world. So you can kind of have a holistic view and then individual views. And it's multi-direction, right? So again, it can either come in or it can go out. And if you have a bi-directional app or connector, then as you're changing something, they can see it and vice versa, right? And I think we have an example of that here. So this, somebody on my team actually kind of built. This is a thing that we've been kind of struggling with for a while is, right, this wall, kind of why we're here, right? Designer, kind of computational expert, right? We go do something, but it doesn't go back to the designer. It doesn't happen in real time. We can actually kind of break that barrier down, okay? And I'm going to try to show a video showcasing that. But the idea is the designer can still be in their tool of choice, and that's the key here. If I'm a Rhino expert or a Grasshopper or Revit is my thing, let it be your thing. But you connect to a bigger world that has expertise on other things, and you all talk to a singular world, as I like to call it, okay? Okay, so this is where we're gonna get a little bit more into the weeds. So I'm gonna kind of break this down into 3 parts. That centerpiece up there called Omniverse Nucleus, this is the kind of secret sauce we have. Think of it as a database, and it's what we call the brains of the operation. So this is the thing that is constantly communicating to any application that's connected to us. Now, you can connect in real time, or you can say, you know what, I don't want to work in real time. I'm just going to push the data at some point. You can do that. So you have kind of 2 ways of working. That nucleus piece can live locally, like I said, on your laptop, your desktop. It could live in your LAN, or it could live up in the cloud. You own the data. We don't own anything. We're just giving you the bits, and you control all the data. The second piece is something we call Kit. So it's our toolkit of how we create apps. So there's 2 apps we put up here, Create and View. Those are things we built out of the box for end users to basically go do things with. So Create is kind of a way to think of it is, it's how I edit a world. So if I want to add physics, or I want to do simulations, or I want to create something, that's what it's there for. View is meant as a review tool, right? It's meant for the project manager, the principal, the non-technical person that wants to view the world. But as you can see, we've kind of broken this into 4 personas, if you will. So we've got the apps listed on the left side there. So the 3 here down on the bottom under the Viz side, we put it there. Those are all bidirectional. The ones up at the top are what we call unidirectional. So it's only data that comes in. And the reason we have that right now is I don't want somebody in the world to go move a wall and then it automatically freely goes back to Revit, right? There has to be a checks and balances. So for now, it's one direction into us. Now, the other key piece to this, the third thing is the connectors. That's what those are. So those are connectors. We wrote some of those. There's many more. I think we have a total of 150 between import and connectors. Again, some written by us, some written by others. Esri City Engine, for example, wrote their own. Bentley's working on one as well. But the key here is on the right now. So we have project leader and clients. The key I want to pay attention to is the little icons we put, right, as to how do I view the world? You need an RTX GPU. And the reason we need that RTX GPU is it goes back to simulation is on an RTX GPU, we have 2 things. We have something called an RT core, which is for real-time ray tracing, right? So everything that you're going to see coming up is all real-time. It's not animated. It wasn't sent out and come back. You see this in real time on your machine. The second thing is what we call our tensor cores. And the tensor cores are what we use for machine learning, AI, and deep learning. Hence why I keep saying simulated world, right? So it uses those 2 things to help you see the simulated world. But the key is we can pixel stream the data to any device. So if I'm on a screen and I have a browser, I can pixel stream ray traced environments in real time. I can also be synced with someone. So imagine being with a client and you're talking through an idea and you want to show him an alternate idea. You could move a wall, you could change a material, you could change the design, and he would see it on his phone, on his tablet, okay? Same idea with VR. We can stream pixels to VR as long as the streaming machine has GPUs. The other key thing is we're multi-GPU scalable. You can work with 1 or you can scale up to as many as you want. We've done 16 and 20 on a single project. So, but the key is that it's the same look no matter the device. That's the other key difference. Okay, so here we're just gonna show a little bit, kind of a one-on-one piece. So Rhino Grasshopper on the left, and we've got a Revit background kind of inside of Omniverse, and then Create is here. So this is actually in live sync mode. So as we're kind of going through, you can see somebody's going in Grasshopper, right? And we're changing nodes. And as he's changing those node values, you'll see an update happening inside of Create. Now, this is on it's on the same machine, they're next to each other, but that real-time update that you're seeing from moving the node in Grasshopper to here, I could be here in Chicago, I could have somebody in California or New York, and they would see that same update happening in real time because of the Nucleus server. Okay, so this gets a little bit more into, so we talk about asset swapping. So this is actually a building we created, and this was part of our talk we did at AU. So we created kind of these shells in Rhino. And then what we did is we had somebody on the team go in SketchUp and actually create the furniture of the apartments that we're building, right? And so with that little CSV table you saw at the beginning, we basically can go say, okay, this shell in Rhino is this thing in SketchUp. And as we're going through, we're seeing this. And what's going to happen is as we change things, we're going to kind of modify something here in Rhino in a minute. And I might be a little fast to the sync here. But as they do the building, now they're going to go. And so that shell is going to come in. And as it comes in, it's going to swap and automatically put in all the SketchUp pieces automatically, right? And literally what you saw, that was real time. There's nothing else. The files were done. It goes and you see it. Okay, so this one, and I got to remember because the team changes the slides on me every so often. So I think this one, we're going to show kind of how we work in collaboration. So in this case, somebody is in Rhino, and if I remember this right, I'm trying to think through. I think in this case, the person is in London that's doing Rhino. And what we're going to do here in a minute, he's kind of exporting some data. Create is now open, and this person is in New York. So what's going to happen is you're seeing the view here, but the person that's back in London is changing the facade and the materials in Rhino and Grasshopper. And the person in New York is seeing those updates happen in real time. Okay, so another way to collaborate, kind of syncing two applications. If you had a bidirectional application, so I'll go back to like Max or Maya, if you change something in one of those, the other one would see it as well because of the bidirectionality. Same thing with Unreal. Okay, so in this one, this is a tool that we actually built. So everything is built on Python. And so we wrote a little Python code here. And what we're doing is we're able to do what's called a variant tool. And we can swap out the different pieces to this apartment complex. So think of it as a building configurator. And as we're swapping it, we can see what's happening in real time. Now, imagine this being connected to an iPad or a VR headset, and that swap is happening in real time, right? Again, physically next to you or in a different location. And then the other piece we built here in this little thing is another little tool to basically say, okay, hey, as I'm swapping these apartments, what's the mixture of the apartments, right? So that was just another little Python piece that was written to basically show how are you configuring the building and come out. So Rob, who's not here, he was supposed to be here. He's the one that wrote this, and I think the variant tool's taken him a little while because we have to go through some things, but that little piece showing you the apartment mixture took him about 5 minutes. Okay, so simulation. So here's another piece. Again, we've got Grasshopper, we've got Rhino. Now we're inside of Omniverse. We took some energy analysis information, and I believe it was through Ladybug, pulled it in here. And so we're looking at the kind of what the building is, and we're seeing how it runs in real time in the different shape. Now what we're going to do is pull in fluid simulation in real time with a sun path. And this sun path that you see was actually built by a customer that's on our community piece, and we kind of used his extension and pulled it in here. But you can see all the simulation in real time. And that city that you're seeing is City Engine that was pulled all that data. So if I remember right, this is about 2 million faces with the City Engine piece in here. And then I think it's another, when we add the building, it goes up. I don't remember what it is. It goes to, I think we get up to like 1 billion with the complexity of the way they built the building. Now, here's another key piece. So iPad is California, and the create screen in the background is New York. So again, they're connected to one central server, and the create person is changing those variant tools, and the person in California on the iPad is seeing that. So they're going to kind of walk through here, and we'll go full screen on the iPad in a minute. So this is fully ray traced that you can go through and look at all these options. So you don't have to be changing any of this, right? Someone else can be changing it and walking you through this. And you could have another iPad user, you could have another VR user, you could have somebody just viewing it on a screen, but you can have multiple connection points and walk through all of this. So, but again, same fidelity between the two, right? And again, if I was in the VR headset, I'd be seeing the exact same thing as well. So, okay. I think we're getting close to the end. Okay, so this was, we wanted to show exactly like how all this stuff was created. So this is showing all the different bits that were used to kind of create what I'll show as the final end slide. But you can see all these little quick videos that were happening in all the different various applications. And if they wanted to be, again, they could be connected in real time, or they can connect, you know, asynchronously, and then when they want to, they sync. But that gives you an idea of all the different applications that were done. And then lastly, this is kind of one of the final images, but everything listed on here is what was used to create this set, which I didn't show all the set, but all of these tools were used from 6 different locations, 5 in the US, 1 in London, right? And it was done in the course of 1 week, from nothing to final slide, basically. That's it. I think I went faster than 20.
Some pretty cool stuff there. Next we have Michael.
Hey, everybody. You guys hear me okay? All right. Nice. Yeah, my name is Michael Hoehn. I'm here representing Buro Happold. So I'll kind of click through here. Let me also keep an eye on time. It looks like, yeah, 3:20-ish. Okay. So these are the quick objectives that I'm going to try to go over today. I'm going to kind of pull the curtain back a little bit on how we work at Buro Happold, how we kind of achieve innovation, what's our process. So in doing that, I'm going to break it down into a couple of different steps. We're going to talk about experimentation, development, and collaboration. If I have time, I'll be able to go through both of these case studies. I'll at least hit the first one, and I might have to fly through the second one, but we'll see how we go. A little bit about me first. So I'm a senior computational designer within Buro Happold. What that means is I'm an architect that didn't want to go and work traditional architecture, but I also love computation. So that's an interesting mix. So I get to work with a lot of engineers on a lot of different projects, a lot of different industries, and sort of bring everyone together using computation within our company and some external collaborators as well. I have my MArch from Columbia, GSAP. And I guess, well, before I go further on this list, the most important character on this is obviously my dog, Bentley. He's my buddy. Yeah, this is us in Central Park. So I live and work out of Manhattan. I'm kind of moving around right now. But anyway, my experience at Buro these last few years, I work on our open source platform called the Buildings and Habitats Object Model, which I'll share a little bit about. I'm also fascinated with the concept of generative design and kind of determining what that means in our industry and how we use these different methodologies and tools. And prior to working at Buro, I worked at Sidewalk Labs, which I think now kind of functions as Delve, but I was a generative design specialist there. And I also teach communications and architecture at the University of Utah. So working at Buro, like I said, we're going to talk about the process more so than some of these really interesting projects that we get to work on, either developing new concepts for housing or construction methodologies or these really fancy structural facades. I'm not so much interested in kind of, exploring all of the different innovative buildings that we have, but I'm more so interested in the underlying processes, the people, the strategies, the scripts, the tools that we use every day teaching. That's me teaching, working with people, collaborating every day in order to achieve innovation. But before we dive into that, really, let's ask ourselves, why are we innovating? Why are we actually here? Why are we, us in this room? We're curious about innovation. We want to push things forward, but why? At least from my perspective, in my limited time at Buro Happold, the last few years, I can tell you that the following 3 categories have been of increasing interest. So our modeling complexity. We've just seen an amazing example from NVIDIA. We've seen them all day and in our workshops yesterday as well, that our models are growing and growing and growing. Every single project, our clients are asking for more and more fidelity, more and more data. Our contractors are asking for more clarity, more information up front. So our models are growing. Our processes are growing in complexity as well. So how do we've already talked about topics like interoperability, computational frameworks, things like that. But, if I'm using Revit or you're using Grasshopper or you're writing your own VBA scripts in whatever environments you'd like, we've got to somehow come together at the end of the day and solve problems. And that can be very challenging. And the last criteria here that I want to highlight is just problem complexity. We're kind of looking at these as what are deemed wicked problems. They're not actually solvable by one specific entity, like climate change, for example. We can't point the finger and say, if you were to do this, then that would solve the problem of climate change. It's actually a number of things that we need to balance. So that's really, at least in my view, why I want to innovate, is to try to move the needle on some of these topics. So to pull back the curtain a little bit, I'll go into a little bit about how we innovate. And this may not be as exciting as seeing like full, digital twins or worlds, but at least this should give you an idea, at least in your own practice, in your own daily routines, about maybe some things that you could implement in order to achieve or maybe to push the envelope a little bit more in your own practice. We'll start here with our philosophy as a company. We try to incorporate fundamental elements of social, economic, equitable, and healthy, sustainable options and solutions. These sorts of like mission statements or philosophies are really great to kind of boost morale and to get people around the same idea, but in actuality, they can be quite difficult to implement at scale. And for a company at our size, I think we have a couple thousand people scattered all over the world in different offices. This message doesn't quite, you can't ask one person in Mumbai what the company philosophy is. They might have a completely different take on it. So what we try to do is kind of let people kind of explore and kind of grow their own stance and what they're interested in, but kind of guide them with certain company, goals and ideals. So just want to be transparent about that. And you'll see a little bit more as I, again, try to expose like some of our processes and what I call an innovation pipeline. And this is something I kind of diagrammed and sketched out as kind of my own process. And I've sort of tried to help cultivate this process. And I'll go through each of these steps within our company, because I think we all have ideas. We all have, partners, employees, collaborators that have ideas. What are we doing to actually not only facilitate the growth and the generation of ideas, but also capturing those ideas and actually creating them, letting them flourish and sort of evolve into tomorrow's innovation. So this kind of consists of 3 distinct categories here. So experimentation, development, and collaboration. I'll go into detail on these. So experimenting. Looking at the first 5 steps here, so just having the idea. And then I'll walk through a little bit about each one of these things. So having the idea, what does this actually look like? So for us, we try to engage in hackathons, both locally, but also kind of, coming to Chicago, going all over the world and having what we have like different office hackathons in all of our offices. Brainstorming sessions, we invite architects, other industry partners over to just have discussions with us and try to open those conversations. In New York, we just hosted the last digital design community event, again, to try to just get people out and get people talking again about some of these topics. We also have one-on-one and group training sessions as well, sharing ideas and feedback. I mean, I don't usually have slides of like Yammer or Microsoft products in my presentations, but I think the key point in all of these things is like, yeah, we have Yammer as a sort of like global platform for communicating and creating ideas. We also have Teams channels where we create these extremely targeted channels where people can go and have these discussions one with another. And then we have on the developer side, which is also public facing, the GitHub discussion pages. All of our repos are open source as well. But the most important thing, I think, is actually we overlay this and kind of understand the phenomenon that's happening when we try to engage people and try to get them to interact, that there's actually a gradient between each one of these. Not everyone is going to want to sign up for a GitHub account to go in and have a discussion about code, but not everyone wants their ideas just automatically public facing. So there's this sort of gradient between, you know, extremely public, more private, topical versus more general that we should consider when we're going through these different types of platforms. And this, again, I'm not trying to say like, okay, you all need to, you know, get a Teams subscription or anything, but whatever works at scale for you is more the principle. For us, we then kind of let people talk, let people create their ideas, but we try to capture them in a central location, what we call as our R&D wish list. And this is very simply put, it's a SharePoint folder that's centralized. It's easily accessible. Literally anyone can go in, and if they fill out a very basic form, they can kind of input their own ideas. And then we have discussions around them, and it's sort of like more crowdsourced ideation. So someone can really go in at any skill level. If you already have a prototype, you can share your prototype. If it's just a sketch or an idea, you can share that as well. So this is really interesting because this is our core competencies matrix that we kind of force everyone to abide, including partners, including our CEO, and anyone who even joins the company. It's kind of like, you know, that we have a kind of standard of care when it comes to computation or technology integrations. So everyone at a minimum needs to be at a level 1. And if you're not there, we help you to achieve that so you can be comfortable, then move through these different tiers of competencies. So you can see like even level 1, I mean, the font's pretty, I mean, there's a lot of text, so apologies for that, but flow-based programming, everyone needs to have an understanding of what that is. What does that mean? What are the affordances of flow-based programming? All the way down to text-based programming, which is writing your own code, your own methods. And for us, it's working in the BOM specifically. So the building status object model, which I'll get into. Yeah, so I've actually seen that. I've talked with several architecture firms and other consultancies, and just having this as a concept of, you know, a core competencies matrix is something that not everyone implements actually. So I share this kind of like, you know, make your own, see what works for you, but this is what we implement. And so developing, right? So going from concept to something that's more developed, and then eventually building the building. So it's Museum of the Future models. So we've got a finite element model, we've got facades and loading paths and nodes and all sorts of things going on that we need to basically work across our traditional discipline boundaries and borders in order to work together to build something. And that's where, you know, you've got an idea, you've got a sketch, you've planned it out, we've talked about it. Now, how do we actually implement and grow that idea? So for, I don't know what that was, but so for this aspect of this, the next 5 steps. So looking at a roadmap, creating issues on GitHub, planning out the code, integrating that into a standard our sprint development pipeline, and then testing and deploying are the next steps. In order to kind of work things into a development roadmap, we again rely on an open platform like Teams to be able to collaborate using a priority workflow planning board. And this again is a publicly facing thing, like all of our, partners down to, graduate level entries can come in and see what we're all working on. And this is where we start to bring people in together and have these conversations. So we can pull in engineer who had the idea, pair them with developers who are ready to be deployed on writing code and creating new methods. We can start to collaborate at this level and write discrete tasks, label things, assign deadlines, and it's publicly visible. This effectively catches all of your R&D wish list items that you've wanted to develop as a company. And then when we move into developer priorities, so this is where I usually take, priorities from our company and our engineers, and then I integrate it into code with the core development team at Buro. So this is your typical, Scrum planning. We follow, sprint protocols in software development. We try to stick to those as standard. But, whatever works for you. I think I've seen also like a lot of us are starting to embrace more software or hardware development methodologies and planning, which is really incredible, like the AEC industry moving towards and collaborating more with that, which I find to be a lot more productive than my standard workflow. But and then this last part here within development is actually tracking your utilization, understanding that you're not going to necessarily make the perfect tool right out the gate. It's going to take iterating. It's going to take some time. So working together with that individual who had that idea, deploying it on projects, having them talk about their tool with their project team. So in this way, we can kind of track like, okay, this was the tool that was developed. And these fancy charts are basically just understanding what version of, in this case, it's the buildings and habitats object model, what version you've installed, what versions are certain people working on, like trying to catch issues and understand certain themes before they actually develop. So these kind of metrics and analysis methods help us to do that. But this helps us kind of stay the course and make sure that we're always kind of making new things and integrating new versions and helping people adopt a little bit better internally. So the last point here on this slide is we rely pretty heavily on GitHub and SharePoint for versioning control. So GitHub's really nice for that. You get that right out of the box. A lot of our code is C#, some Python as well. But SharePoint is great for like Grasshopper scripts and documents and things like that for version control as well. And this just pointing towards the future and working towards a common goal. So I say before, like using our philosophy, our company philosophy to sort of guide what we're working on. This is, at least in my team and anyone in our company who's working on tech, like this is what we're aiming to achieve. This is what we want. These are our goals. This is kind of my personal guiding light. I'm working on this specific project at this time to achieve this. And where does that fit within the larger roadmap? And this, it's not a very beautiful diagram, but at least it's something that helps us, understand our place in the overall structure. And I think that's been super effective, at least the last 2 or 3 years. So. And then the last point that I'll cover here is collaboration. So pulling together lots and lots of disciplines, lots of stakeholders in order to actually build something, actually innovate. So collaboration consists of a couple of things. So we've got sample scripts and your return on investment, so other tracking metrics as well. So this includes things like, I begin talking about the core competencies matrix and how everyone needs this sort of uniform understanding of what we're working on together using computation. How we actually collaborate internally, at least, is by having these global Academy sessions. So this is where we actually make time to visit. So that list right here, a list of all of our offices and their dates and times of when we're going to be coming by, when we're going to be sharing skills. We have really targeted, like this is what this office needs in order to not only just build their building and finish their projects, but what do they need for the future as well? So we try to, gauge them before we actually get there and make a plan. So the Academy is a really great forum for that. It does take a lot of time. Like you can see, it's pretty much all year. We have something happening every month or two because of the amount of offices and people. But this is something that keeps us on rails. It keeps us on track so that we know we're building continually. And that's something that takes a lot of effort. And admittedly, like, we don't have enough resource right now to just continue to do this and continue to put the energy we really want to. It's a very difficult thing to try to pull off. But it's something like, if we didn't do this, then our company's culture would suffer as well. So we've got to, weigh the pros and cons of this. But we've been doing this now for, I guess, going on 5 years. We've been doing this regularly. So, and it's been a real help. And then again, I'll show this. This is specific to the first case study that we'll go over. But when integrating our internal sort of grassroots product that we've developed, which is the Buildings and Habitats object model, we like to see, who's using it, what's the project, all of those things. So we've integrated a really simple UI that asks you when you boot it up if you work inside the company. If you download it, publicly, it won't do this, but we like to be able to track so we can help and see, okay, we've got, 100 people using it in this office on this project. We need to assign a little bit more help, targeted help. So we use our metrics like that. And at the end of all of this, like, we're all in this together. So this is our wheel of all of our offices, all of the people who contribute to the code base, as well as the people who are using it on projects. And this was a snapshot taken some time ago, so it's not current, but it is something that sort of reflects just the overall usage of our internal tools. So you can kind of click on a different office, see, what that person's up to, who are they working with. And I think most importantly is the connections in between. So it's not only the person, who are they working with, but it's also what tool they're using. So it's kind of, drawing up these complex connections between the individuals and the tools they're using as well. So I think I'm running pretty short on time, but I'll at least go through this, this first case study. I've talked a little bit about it already, but the Buildings and Habitats object model, the short form is BOM. You can't talk about it in airports, but we get by. It's essentially co-authored know-how. It's how we are attempting to connect everything to everything and everyone to everything, right? Ultimately, I mean, we've all seen sort of diagrams like this even today, but everyone should, make your own solutions, make your own tools. But that does, and I think we need to talk about, and we have been talking about, the relationship that does cause some redundancy in our workflows. So what the BOM is trying to do, and it's not the only one even at this conference, is it's trying to just create a common language that we can talk across all of these things and not worry about file formats or anything like that. So, and because there are some other interop specialists in the room, that's great. Let's interop with interops. So not a problem. But then to sort of move on, because we're talking about like continuous integration and continuous innovation. I pull up this chart because this is kind of showing the rather slow growth over, and I don't know if I have the dates on here. I don't think so. I think I removed them. But this is kind of mid, 2005 over at the end here. I want to say is when it kind of first started internally as a closed source project. But then this sort of slow growth continually, like kind of rolling it out and trying, and it's a grassroots thing. But you can kind of see some of the milestones that we had to hit that kind of encouraged greater adoption or encouraged involvement in the project. So when you see things like drive for greater participation, these are things like hackathons or hackademies that I mentioned. And then we get towards the end where we're starting to ramp up continuous integration protocols in software development, bots, things that you can kind of call on in GitHub to get help to formulate or help format your code, which have been a huge help for people that don't know how to code. They can just say, hey, can you help me, pass compliance checks or get my method merged? These are the kinds of things that we've had to kind of think about over the last few years to help with continuous growth. And then just to show you kind of the ebb and flow, we've talked, I really like that analogy of like, if you're kind of this stagnant line, then you're not growing. I mean, this is kind of the heartbeat of the BOM right now is our commits per day, our issues per day, and then our pull requests merged per day, up to, I think, 2 days ago when I finally finished my slides. So it's not this, perfectly, linear or perfectly exponential growth, but it's something that we kind of keep the pulse alive. So ultimately, the job, like I mentioned, it's an interoperability platform, so it's able to push and pull things seamlessly between lots of different software suites for engineers and architects to work together. So in this example, it's pulling from a Revit model, pushing some section of the Revit model into ETABS or Robot, and then working with Grasshopper for, let's say, shading analysis, solar analysis, or circulation. You can do those things as well. But ultimately, what I want to end on, because I think I'm out of time, is that you really don't have innovation ultimately without the people, without the processes in place. So what we like to focus on is mass participation. So how can we encourage, creating ideas, and then what are those frameworks? Hopefully, I've kind of done it some justice today with our framework internally, at least. Maybe that sparked some ideas on how you could also integrate them into your own practice, but we'll leave it at that. I won't go into the next case study because I think I'm out, but yeah, appreciate your time, and thanks for having me. Yeah.
Perfect. Next we have Chris from Kieran Timberlake.
Okay, well, thanks for having me. This has been incredibly inspirational. That was a beautiful presentation, beautiful charts, a lot of commits. We hope to one day get that many commits. It'll be a while probably. So I'm Christopher Connock, Principal, Design Computation Director, and member of the research group at Kieran Timberlake. We're a community of about 90 architects, landscape architects, sculptors, chemical physicists, a few computer scientists, environmental researchers, and building performance specialists. And we do projects. We do projects that are large and require cranes. We do projects that require magnification. And really, throughout all of these projects, we recognize that to innovate, if that's the topic of discussion today, at any scale, we need to plan for feedback loops. We need to distribute agency and really build a discourse over the topics that are important to us. So today we'll give a kind of a short history of how we've introduced new methods or ideas or products, which I think is the Oxford definition of innovation. And we'll also end with kind of strategies for that we've leaned on when tackling questions that are at the edge, maybe at least our edge, maybe your edge of our knowledge and of our practices. So we feel really at the core of it that architects should not simply consume knowledge, but create it. And on a project level, that means understanding the before and the after of our built works. So our plan, do, monitor, learn ends up taking the form of collecting, observing, simulating, and prototyping. So that may mean going back to the many green roofs that we've designed and seeing where the winds have taken our meticulous plans. We might go to an urban site, a gritty Philly park, and understand all the action that's happening there before we put pencil to paper. And we'll also try to simulate to see the future. And sometimes that will be some, kind of rote simulation. Sometimes we'll be pushing our boundaries and trying to understand phase change modeling, as you see in that picture. And then finally, when materials come into play, we like to work with them at real scale in our shop. That's looking at kind of a pleated window across a whole facade and kind of modified glazing. So really throughout all of this, we build tools, but we understand that design practices are not really centered on technology. And I think that's a theme here, but on people who create knowledge collectively. So each time we do this, we kind of rethink the relationships to each other, to our tools, again and again. We also take advantage of our projects as test beds. So on one single project, we have many kind of a multi-method approach at interrogating the before and after. Sometimes the kind of lifehood of a project is not long enough, and we want to thread that through multiple projects. So very often we'll take advantage of smaller projects and thread that needle of material innovation, in this case, in terms of thin multi-layer kind of envelope films, from smart wrap to a home, still an exhibition at the Museum of Modern Art, and finally to an institution, the new embassy in London. We'll also work with and partner with people who can expand our expertise. So we've worked towards architecture as a product, partnering with Bensonwood, Living Homes, and Moderna to create prefabricated modular housing, to have a kind of a closer connection to production, and understand what it means to kind of apply system thinking to architecture. The final one, Open Home with Bensonwood, I know Rob was talking about, what is the value of architects getting squeezed by automation? Try working with a timber frame artisan who also embraces plant fabrication and automation. It's a humbling experience, and one that we enjoy as a challenge to find out, where do we add value to their product. So in addition to kind of finding threads through projects, finding partnerships that we can rely on again and again to explore new ideas, we've also made some bigger bets on issues that we think are kind of critical, not only to the occupants of our buildings, but to the practice and those who it impacts. So one of those was tally. We've been basically interrogating the kind of the greater lifespan of our buildings since Steve Kieran and James Timberlake wrote Refabricating Architecture almost 20 years ago. And we wanted to understand the impacts of our buildings beyond construction, beyond the construction site, and life cycle assessment provided a method to really kind of track those effects from extraction to the end of life. But at the time, it was a practice typically applied by specialists at the end of projects, really not something iterative that can inform design, at least when we were kind of interacting with it. And main reason for this, also this kind of late phase interaction of experts, was that we needed a bill of materials. We needed to know what was in the building to really have a holistic understanding of the life cycle. So in a Revit, problem solved, right? Not really, we all know that. It sounds like, this might have been news 10 years ago, but even though Revit is theoretically a database, a flat one maybe, it is not actually representative of what we need to perform life cycle assessment. So that wall type you see on the left does not contain the resolution that we need to really be able to understand all the materials that go into a building and where they came from, how they'll be maintained, and how they'll be taken off the site when the building's useful life is over. So we developed Tally. So this kind of early question about LCA, really, it forced our hand in terms of not just wanting to produce a tool or to answer this question, but we needed to partner with people outside of our expertise. So we partnered with ThinkStep, now Sphera, for that really valuable LCI data. So the data behind all the materials that we would build up into assemblies. So we had this kind of partnership for data, and then we started to kind of decorate that and build out assemblies and build out an interface that would allow you to essentially do much more complicated takeoffs from the Revit model as a kind of a basis. So that would essentially allow us to take what were kind of design intent models in BIM parlance to something that could actually produce LCA analysis and insight. So we also took another bet, and so we have not really only focused on the kind of the global scale impacts of embodied carbon. We've also looked at the immediate experiences of the occupants themselves. So sweltering summer in a naturally ventilated Philadelphia office, our office, led us to develop really a sketch of an occupant survey app early on that we further fully developed and actually had users outside of our office that incorporates essentially domain-specific expertise in surveying and the lessons learned, the sweat earned of our office for that summer, naturally ventilated into this kind of easy-to-use interface that includes survey taking, as well as a capturing of spatially explicit results. So you see here, after someone takes the survey and places their location, it's a little nosy also what they're wearing because we want to have their CLO value, what they've been doing lately. So we have their metabolic rate. We take all that information and we can actually view it in an easy to understand graph that with a corollary kind of plan view. So to recap, because this is all history, some of it ancient, maybe to this crew. Tally is now actually in the capable hands of Building Transparency, a nonprofit. And Roast we launched right before a pandemic sent everyone away from the office. So that was fun. But we are rebooting. We're updating to meet new standards, and we've been pushed by our users to look at well version 2. So that's exciting. We're looking at how to track that in addition to lead and well v1. But I wanted to also talk about today some of the strategies we use for new topics. So at one point in our life cycle, these were topics in which we felt people should talk about. And so we essentially made tools as it was our microphone for these topics. So I'll quickly, talk about some new topics that are kind of emerging that are on the our edge that we're interested in, and give a few kind of very basic strategies for how we tackle them. So this one's probably the most basic. As professional problem solvers, as tool makers, we often jump to solutions. So the simultaneously open yet rigorous act of question asking keeps us focused and often leads to new knowledge as opposed to kind of reinforced assumptions. We ask questions, it's just part of our daily existence. So if we're talking about how we work as an office, for every project, we start with a red report. So this is a report that is initiated by a researcher at Kieran Timberlake in conjunction with all of the architects, communication specialists on the team that looks at program, climate, resources, code, infrastructure, and guess what? It's framed by questions that we have related to all those topics. Every phase of a project, we have tools and workflow sessions. Those are sessions in which the team and then other people from other teams, to make sure that we don't reinvent the wheel, get together in a room, virtual or physical, and ask questions. In this case, we ask what we want to know and what methods are already existing to get us there. So this question asking is an active art. We do it all the time. And also, as you can see here by the struck gray words, that oftentimes our questions change. And that's okay. We encourage it. It means that we're asking more questions. Oftentimes those questions change because of really embracing a transdisciplinary mindset. So what does that mean? We essentially have these kind of like wait what moments of different domains colliding. And often that's where I think most of the innovation, sometimes frustration to others, but I think innovation comes from. Some examples of that might be meetings in which you are talking about workflows and someone says, wait, your model doesn't include trees, or you only ask that question once, you only ask people how they feel once, or is that data include something other than the US? So we always have these moments where one person's expertise, be it in architecture and sculpture and landscape and chemical physics and computer science, collides with another, and they ask that question. And so really, without getting into the nitty-gritty of the hyphen-disciplinary world of intra, cross, multi, inter, and transdisciplinary, we view transdisciplinary teams as ones that work on the whole project. They will always have their own domain expertise. That's why they're there to a large degree, but they set aside their disciplinary hat. So knowledge is ideally not just exchanged or integrated, but created. And I really do think that's as close to innovation as you can get. It's also really hard, especially for an industry that is, it kind of builds on a bedrock of contractual scope separation. And so how do we do that? So I think one way we do it is we try to model it internally. That's why we have a research group. And within that research group, that we are not all computational specialists. We all speak, because that is a core competency, the language of computation, but we have backgrounds in other fields. In particular, recent hires in environmental research and circularity have kind of created new wait what moments for the team, and kind of prodding us to expand what kind of ideas we let into, what kind of parameters we let into the systems that drive our design, which leads to another common pattern that we like to embrace. This is what for Tally and Roast, advocating for new system boundaries. So for us, innovation usually happens at the gaps, or these unseen overlaps before we have those wait what moments between systems. So when investigating new topics, we're constantly working to understand these complex systems, the logic used to define their boundaries, and really, we think a diverse group that owns the whole problem and asks questions is primed to challenge the kind of the technical and ethical concerns of these systems and disciplines. So 2 new streams of research have emerged from a recent expanding of these boundaries. While we had tackled global embodied carbon impacts with Tally and attempted to understand the kind of more localized impacts on occupants at the scale of a building with Roast, we wanted to really kind of combine these 2 concerns. How could we understand the impacts of our built work on people at a larger scale, in line with the global nature of the supply chains that kind of drive the materials with which we work? So that's led us to 2 new topics that we're really excited about. If anything from this talk, if you haven't engaged with these topics, just seeing these would be good enough for me. I'm really fascinated by them. So the first one is environmental justice, which is really, just equitable treatment and meaningful involvement for all people in regards to the environment's impact on them. So in the US, disadvantaged populations, poor populations have a higher share of pollution risk due to land use policy, placing plants near fairly highly dense housing. So this is a real issue that similar to embodied carbon and similar to some of these larger environmental impacts that we felt needed more attention, needed an attempt, however early and larval, at quantification. We're also looking at supply chain social equity. Right now, this goes, I think, by many, many phrases, but essentially, if environmental justice expands our concerns to the people affected by the environmental impacts we create, supply chain social equity looks at extends those efforts to basically the people involved in the actual production, extraction of the materials themselves. So how do we start interrogating those? How do we innovate within those spaces? We challenge respectfully disciplinary data and modeling habits. So really expanding system boundaries is a foray into fuzzy and gap-filled data with their own history of construction, their own biases, plenty of caveats, but plenty of potentials as well. And so we try to carefully hybridize our research and computational methods and examine new correlative techniques and try to really apply multi-scale modeling with all the respect, restraint, and verve that we can muster. I'm missing a line on the preview. It's there. So this this chart has a large blue line right between embodied carbon and ozone depletion. with the label global and local. So we can use our imagination late in the day. As designers basically normalize the practice of BIM LCA, right? So tally, connecting models to environmental impact. Their interaction with the underlying data sets presents an opportunity to evaluate building materials through an environmental justice lens. And so what we found is that while you have embodied carbon and ozone depletion on a global scale, there are other impacts that are local, and that starting to look at populations within those, we can actually build out an environmental justice index. There we go. Oh, wow. So that's the imaginary blue line now made real. So an EPD's strength. So if in Tally, we, as our final phase of work with Tally, connected Tally to EC3, which you all have heard, that leverage environmental product declarations. So basically documents that are the kind of the report card of the products, materials that we use. Those are simultaneously, they're simultaneously very specific, which is their strength in one way, and they're hyper-specific to the technology, the process, and the location for that product they define. So EPDs have become our kind of way into tying kind of environmental impacts to people and place. You can see here that factories, in this case, aluminum smelting factories are not created equally depending on where they are. So once we have essentially an EPD, so this is essentially giving us the manufacturing location and the LCA results for a particular product. We can identify the specific community and people impacted, and we can see if they are in historically disadvantaged communities. So that's what you see with EJ screen data for income and there. We can also look and see if those communities might have potential human health concerns that you see, right, that were with the CDC Places database information for asthma and high blood pressure. And then we also know exactly what type of pollutant ideally is being emitted, and we can use place-specific modeling and wind dispersion to understand basically how much more pollution that area could absorb based on kind of healthy air kind of criteria. So what this is doing, right, is it's taking basically an LCA product that we had been familiar with before, and we're trying to, again, expand that boundary, zoom in within that boundary, and find indexes that can start to give designers more criteria. So these are not answers. This is not a single score right now, but they do give more criteria to start to make decisions about the materials they use. So in this instance, if you were trying to determine what product you would use, you could use all the information on the EPD in addition to this data. So this looks like if this is the kind of 10 mile radius here, you basically have these indexes displayed spatially to help you understand that product and its kind of impact. So this is all larval. This is hot off the presses. Kieran Timberlake partner Billy Faircloth and Principal Ifri Escott just presented this at the Design Modeling Symposium. We're continuing to work on it. I think the strength that I mentioned of the EPD, its specificity, is also right now a weakness because they are so specific that you need coverage, right? So go to the Northwest and you might have 30 options and well-documented EPDs based on industry adoption. Go to the Southeast, you may not be so lucky. So there's a lot of work that we need to do to kind of build up that resolution, that commitment by industry partners to really give us the information to work with. So then the last piece, when we talk about kind of supply chain social equity, we've also been working on a lot of lit review, a lot of questions regarding how we frame this topic, but there is also an embodied suffering toolkit made by Michael, actually in the audience, along with kind of collaborators at Yale and Kieran Timberlake, towards taking a similar approach to attempting to unearth forced labor within our building practices. So this is just starting. It's in a GitHub on as a toolkit, but it's really looking at what happens when we start to collect mosaic data regarding labor exploitation, tying that to generalized material import data, and then because now we all have parametric models, the quantities of our models. So those are just two topics that are kind of on the edge of our understanding that we're sussing out. I think the last piece is what we're doing right now, and I think it's great, is share your stories. Accessible explanations for the connections behind our data and tools are just as important as the data themselves. So when teams work with data from different disciplines, notion of what is accessible must expand beyond that data being simply public to something that's understandable by a layperson and machines alike. So sharing the kind of the stories behind our connections allows wider audiences to question and build upon that new knowledge created. So that, takes the form in terms of the classic monograph or treatise, but also, we've learned that when it's almost kind of the opposite from the last few panels where they talked about if you have a problem that 100 people are doing and trying to solve it, most of the tools that we've done we make them because very few people are trying to solve it and we want more people to. So they're more often acts of advocacy than of profit generation, but they really rely on not only kind of putting a tool or an AEC out in the wild, an FTP site or a CSV floating in space. They require advocacy, they require training, they require contextualization. And I think that is really critical as we move forward when we find topics that we're passionate about to not only produce solutions or tools for them, but a discourse around them as well. And finally, we do that externally, as you saw, and internally as well. When we are dealing with larger issues, we talked about 2030, that's being talked about. We as an office want to understand how we work. So making sure that we have lenses and narratives in terms of data, in terms of graphic visualizations, in paragraphs, in summaries, executive summaries as well. All of those ways of describing the problem and describing our current condition are critical to kind of solving these questions at the edge. And that's it. Thanks.
Perfect. And last but not least, Heath May.
How's the volume? Okay here? All right. So first, thank you. I'm honored to share the stage with fellow panelists here. Man, Omniverse, amazing. Michael, the work that you're doing, I mean, that it's so educating to me, just in terms of how do we implement, how can we get things done? And then Chris, we've looked to you guys as an inspiration and a model for many years. So I will attempt to do justice on sharing the panel with you. My name is Heath May. I'm an architect. I got here through a circuitous path. I studied art and biology, kind of finally found my way to the profession. About 9 years ago, going on 10 years next year, we established HKS Line. And what is Line? Well, it's an acronym for Laboratory for Intensive Exploration. And we do a few things. We focus on simulation, computation, and fabrication. And we're an R&D team, kind of under the larger umbrella of HKS. We float somewhat autonomously, but we do that while being a fully self-sufficient design studio at the same time. So the computational design work, it's very much tethered to design. And I would say that you could probably look at this through the lens of applied research in terms of what we try to achieve with the way we work. But really what Line is it's these people. So I'm privileged to talk about some things that we've done and we put together. But I get to work with some really smart people. And we've put together a team of people that are not all architects, and they come from a variety of backgrounds. Music recording, computer science, environmental engineering. There's a few architects here and there. We've had many people that have come through the studio over the past few years that have gone on to engage in their own startups in their own industry. But we're trying to operate at the nexus of art, science, and technology. And that's something that's been formulated in my mind for many years. And then there was a book that came out with Bruce Mau this year that kind of talks about exactly that, the nexus, and how it's those overlaps that Chris was talking about that I've always found interesting. I think that was why it was hard for me to find architecture, because I kind of like the edges of things. And so this is a quote from that book, talking about solutions depend not only on good ideas, but the ability to execute, right? And having a diverse team is really important to that. And then there's this idea of the best way to come up with a good idea is to have lots of them, right? And I'm probably projecting some of my own inadequacies here. But for me, coming up with the ideas isn't the difficult thing. I've worked as a teacher at the University of Texas at Arlington's College of Architecture, Planning, and Public Affairs, teaching graduate design studio for a few years. And one of the things I often tell my students is there's 1,000 ways to approach a project. Just pick one and execute it really well, because you're going to learn something from it. But Bruce really breaks this down in this book, Nexus. It's ideas and implementation. And that's kind of a theme that we've heard. And so I want to talk a bit about both of those. And if we start with ideas, Saul Wurman, the creator of TED Talks, he wrote this book called 33. It's a beautiful book. I would recommend that you read it if you can find it. But in it, he argues that whenever you ask someone what's wrong with the current state, most of the time they'll start with, we need more of or less of something. And he said, if generally when you're talking about that, you're on the wrong track. And so I've tried to remember that. So the way we approach something in order to find the best ideas, it's not so much about more or less, but it's about move to think. And I think of it, I appreciate the Mustafa's jazz analogy earlier, because that improvisational kind of collaboration is something that I've always kind of felt really closely resembles the way I would like to work in the industry. There's a musician, Victor Wooten, that talks about don't lose the groove while finding the note. And so that's the thing, is this move to learn. We stay really busy and we make problems for ourselves, quite honestly. So many of the things that we explore or that we try to work on, those aren't handed to us as part of the brief. Those are things that we create on our own. And we often find those ideas through a big what if question. And so we've heard from others about, this idea of making questions to make ideas. And I'm just going to talk about one project today. So I thought a lot about what could be helpful. And I think, the way maybe I can insert myself into this conversation is just talk about one thing. And we had a big question. What if we could deliver a project without paper? Or, maybe the whole facade of a project without paper. And what I mean by that is not just like automating the paper. We've all probably written scripts that could like churn out some drawings that we can come and pick up the next day. But really deliver it true digital delivery. And we had an opportunity to work on this stadium here. This is SoFi Stadium in Inglewood. If anyone has been there, we'd love to talk with you about your opinions afterwards. But opened up 2 years ago, hosted a Super Bowl. And we did this. We delivered this entire envelope without any paper. And I'll talk a bit about how we did this, why we did it, some of the challenges and some of the ways we approached it. So the envelope here, I'm going to flip through a few images to kind of get a sense of the project as a whole. It goes over not only the stadium, but Champions Plaza, which connects the stadium to a performance venue. And it sits in the middle of a 350-acre redevelopment in the city of Inglewood. And, thinking through this, there's just so many things that go into this, and the line team, add 50, 75 people to that. And that's just a piece of the design team that was part of a project like this. And then we have all the people in the field, right? The people that are actually putting things together. So it's a really big team. But I can kind of admire this because I wasn't a part of all of it. We work as a consultant and as a design studio, and this was a job that we did as a consultant looking at the envelope. So achieving a few different things here, but we're going to really focus on the envelope and the skin itself. And this was conceived of an idea conceptually that was a meaningful image that could be appreciated in abstract form, but it also had some connotations to the waves at the beach nearby. And it's permeable, because we're really trying to situate this project in Southern California. So walking through some of the things that went into a project like this, there's many challenges to doing this. One of those were our proximity to LAX, to the airport. So we had FAA height limitations. And one of the things we had to think about, that it wasn't just the built height that we had to maintain, but where were the cranes going to be during construction, and trying to kind of think toward the future, from the very beginning. And so that led to a few big moves. One of those was nesting the field and the bowl down. So you walk in and the procession leads you down instead of walking up to your seats. There's this idea of shelter, this big roof form that becomes kind of the recognizable feature, the elements and how that's shaped. It's non-Euclidean geometry. It's not an immediately rationalized surface. And so there was a lot of heavy design, computation, rationalization that went into that surface to achieve what we were trying to do with the geometry. A lot of structural lateral optimization for seismic decoupling of the envelope and the bowl itself. And then this idea of a big aspiration for no HVAC. Could we make this a comfortable place for patrons all of the time through passive cooling, and really tune it to work in its environment? And then a lot of the program synergy, that I talked about. It's really a stadium and a venue that are connected by this big roof. And so how did Line engage in a project like this? Well, we jumped in initially thinking about this aspirational vision is really built on rigorous research. And we came in with a climate brief, an initial document, 80, 100 pages that you just kind of drop on the table and it shakes a bit. But we look at the climate through the lens of systems thinking. And what we're doing is we're creating kind of a design team guide to how we'll approach the project. And what that sets up is working with the client, working with the design team to understand what are our primary goals, and then setting some primary, secondary, tertiary, and even some of these micro strategies to encourage a redundancy there for resiliency, to try to achieve the human comfort, the homeostasis that we're looking for through this effort. And so part of that was the operability of the ETFE roof system. And so that's something that has the ability to move. It can kind of crack open like your car sunroof. There's different operable panels that can be opened, automated or in response to the local conditions, so that you can improve the airflow through the stadium. And the building really becomes to function like a machine in some ways. One of my favorite ways to experience the envelope is looking from the inside out, because you get to see the primary structure, the space frame, and then the tri-skins themselves, as the last object that you're looking through these layered systems. So I wanted to just set the context there in terms of what we were trying to do. A few images. So implementation. So the idea was there. An open air stadium, protect people from the environment. How do we implement it? Well, this is where the people part comes in. And so the first thing that we had to do, and this was kind of coming off of the heels of the Digital Fabrication Network conference in San Francisco, sometime around 2015. I caught up with Rob right before he left, but I think he was there. A few of you in the room may have been there also, but the topic of conversation, was a group just like this, there was a lack of a model of record. And there were fabricators there were artists, there were engineers and architects. And we were all lamenting, we could rely on drawings. We have a right of reliance on drawings as an instrument of service that can be stamped and sealed. We could pass a model under the table, but we couldn't stamp and seal a model. So we're using it at tremendous risk, right? Well, I was just young enough and naive enough to come home and say, okay, we'll figure out a way to do that. So we called the California Architects Board and we said, hey, we want to deliver a big piece of this project with no paper. We want to stamp and seal digital assets. Luckily, the person didn't hang up. They said, okay, I need you to write me a white paper to tell me what you want to do. So we did that. And the next part of that process was, build a functioning prototype of what you're trying to do. So we built a tool, an application that could do that. But this is really just kind of an overview of what we did. There was a lot of intensive computation and visualization in the image processing itself, going through abstracting this image. The upper right shows really the way that we delivered a lot of this project. All of the geometry was kind of carried through the project in CSV format, a text file. And we started in Rhino and Grasshopper, went to Python, eventually ran out of all the consumer off-the-shelf software that could do what we wanted to do. So we took it to a custom C# environment where we kind of finished it all out. And in doing that, instead of the paper drawings, we were able to deliver tens of thousands of these unique text files that had a comma separated value format to them for all 35,000 of these unique tri-skin panels. And so these all had a unique perforation pattern, unique geometries to them. And it would have been incredibly difficult, I won't say impossible, but difficult to draw these. And so this was an example of the project initiating a need. Client didn't ask for it. Nobody asked us to do this, but we recognized that this was going to be hard to document in a traditional way. And so what that did was it allowed us to deliver all of that information directly to our fabricator partner, Zaner, with very little translation straight into G-code. So it was driving the machines on the shop floor. But what it required was that we ask questions early on. I don't want to be constrained early, too much because we're thinking, in a divergent way, but understanding things all the way down to the diameter of the different punches on the rotating bolt head, helped us work with that intelligence from the very beginning so that we knew what we were dealing with, looking at even the coils of material we saw and what the constraints on the dimensions of the individual panels were. Could we achieve the curvature there? I'm going to kind of blow through some of this design process, the implicit imagery that we worked on, working with the coined die punch. We learned in the process of the mock-ups that punching the material put a coining on the back that actually stiffened it enough that we were able to drop down a gauge. So that was something we discovered as part of the process. But by working in a model, we were able to carry our ability to affect change a lot further into the process. And so we were able to stay in the model even when construction had started because we never had to stop and hit print. And the envelope itself, through rigorous analysis, reparameterization of the facade, we were able to sometimes even increase surface area to decrease curvature, to decrease cost. And so this component of the project actually came in under budget, and we had 5 FTEs through the whole process. And so that was something that we took on as a challenge, and it actually worked in the long run. Where do we go from there? Well, we patented the process that we did, the methodology, which was using a secure hash algorithm to give a unique identifier to each of the files. It could be then validated and stamped and sealed by someone who received them. We've licensed that to a company called Concert VDC. And where they are right now, they are spinning up and ramping up. Got a crew on the ground in the Bay Area coming out of the Stanford computer science program. But they've taken the methodology that we used for SoFi and they've merged that with blockchain in a way that provides that authentication and validation of the digital transfer of assets, now with versioning control. And that opens up an incredible world when you start to think about that, the way that we're sharing digital assets, having the ledger and the versioning there. We always know exactly what is the latest. It's also opened up a lot of collateral opportunity beyond fabrication, insurance, subcontractor pay stubs, submitting something for approvals. The blockchain, I think, in this manner could open up a lot of opportunities. So Concert VDC is going to take this It's an industry-wide platform. There's a lot of signatories that are already using the service right now. And we're working with local AHJs to try to kind of pave the way. So during the process of the project, it took about an hour to walk around this when we were out on site. And one of the things that I want to kind of pose here, questions that I'm thinking about is what if we could walk the site together without physically being on site together? And I think what you're working on is going to allow us to do that, because there are things that we could see despite spinning around in the model for years. You could see it on site immediately, but you never detected it in the model. So QA/QC, that's something we have to think about when we're no longer working with paper. Revisited small, medium, large, extra large the other day. And, first few pages, there's this quote. And I think it really, to me, kind of summarizes what we're dealing with here and where innovation comes from. So my question is, what if we didn't depend on the provocations of others? And my encouragement here is, let's start with the first creative act. Let's interrogate the brief. Let's think of ways to create problems for ourselves. Thanks.
Thank you. If we can get the panelists to join us for our Q&A. Awesome. So that was some really interesting presentations, varying in like really vast degrees of, as a theme of the talk is, innovation and practice. And it kind of, you kind of almost want to need more time to kind of unpack what that really means, because you folks are really going at it, whether you're at a firm scale or at an industry scale, you're really hitting it pretty hard, right? So how do you stay innovative while also still being able to keep the practice going? Because the practice needs to keep the lights on, right? And at some point in time, in order for you to be innovative, you kind of have to sometimes pull yourself away so that you can kind of take off the blinders of the projects and the blinders of the kind of the grind, but then bring yourself back in. So how do you balance that out?
Well, I have the mic, so I guess I'll go first. I think, we're talking about, like, with the company that I work for specifically, I guess is fortunate enough to have multiple departments and people. Like, we can kind of facilitate some teams not necessarily innovating or creating brand new products or taking things to market and allowing other people to focus. And then it becomes a question of, like, how do you keep that wheel turning of letting people experiment when they want to, and letting people work and dip into project work when they want to, and pull out of that and start to, make new scripts or make new tools. That, like, I don't think we found the perfect recipe for that. I mean, engineers are highly efficient beings and they want to stay highly efficient. And when you dive into innovating, you suddenly kind of feel less efficient. You're like, I'm spending more and more time, breaking things than I am actually making things. So, yeah, I mean, just for me, it's kind of a different perspective. Like, you're trying to keep that wheel turning of, like, what different people get to work on. That's kind of where we're at. But.
Yeah, sure. Yeah, I wish we were efficient beings like engineers sometimes, but I think we're always project embedded to some degree. So we're a much smaller scale, but we have essentially on every project a coordinating researcher. So throughout the research group, we always have some link to a project, to the daily needs of a project. I think that helps inform the bets we make when we innovate. It also gives us kind of respite from, is anyone else hearing like an amazing other one? Or
there were more, but I think they're back there. The mic is kind of echoing.
Yeah, I'll just, there we go. Is that better? Thank you. I get that. Yeah, so I think I think that embedded nature is key, and then also the idea that it's a pretty nimble embed. When we embed people as we call them coordinating researchers for a reason, they are not doing all the research on that project. What they're doing is they're identifying opportunities for interjection of research onto that project, and then kind of tying back to our greater resources. So I think that lets us have our cake and eat it too, to a certain degree.
So I guess I'm going to be the abnormal one here, right? A little bit. So it's interesting. So when we look at things, it's I'm kind of looking at it from two perspectives, if it makes sense, right? It's from what you guys are doing and how can we help solve that. But then it's like the people that are inside of our company are rocket scientists and beyond that, right? And so they're always developing something, and it's how do we take maybe what they're developing and apply it to what you guys are trying to do. So we look at it as kind of like a connecting of the dots, right? As we're kind of building this platform out. So I look at it a little bit of a different perspective, but I think the key thing is we have to talk to one another, right? If we're not talking to one another, then we're not going to try to accomplish what we need to do.
So going back to the title, innovation or practice, like at some point you innovate to a certain degree where you almost have to redefine what the practice is, right? Traditionally architects build buildings. I remember my professor saying, the goal of the purpose of an architect is to build safe and beautiful habitats for humans, right? But now we're in a time where we have to kind of go beyond that. We have to look at social issues, the pollution issues, global issues, that sort of thing. So how can you define, or how do you see practice? Let's go that way. How do you see practice changing as we are innovating within this industry and we're changing kind of the parameters that affect our work and our outcome?
Yeah, I can jump in that one, or try to jump in. Someone earlier talked about the complexity of these wicked problems. I think it was you, Michael. And there's a book called Hyper Objects where they talk about these things, these wicked problems that are just too big for us to comprehend. It's like a thunderstorm. I can kind of comprehend the thunderstorm as an individual, and I can comprehend a raindrop falling on my face, but I can't comprehend all of the raindrops falling at once, type of a thing. So climate change is one of those. There's a lot of things that are now part of the contemporary global issues that we face that have changed, but our professional obligations remain, right? So there's still that obligation we have to the health, safety, and welfare of the public. So I think, Chris, your presentation was a great, I think, leading by example of how we began to intentionally put together teams that can tackle these types of wicked problems that aren't just architectural problems anymore, right? There's a social aspect to that. There's things that are just above and beyond even the way we practiced 15 years ago. So I think the intentional way we put together those cross-disciplinary, interdisciplinary teams is where it starts.
Yeah, I totally agree. And I'll add to that, just seeing Chris's presentation, I'm really glad you tossed in the bit about our collaboration. Actually, we're on meetings together weekly, actually working towards what we're calling the embodied suffering toolkit within the BOM, and sort of not only writing the code or the methods or making it interoperable between different UIs, but the theory, the social component, the data, all of those things have actually taken or kind of required us to reach across the table and say, as engineers, we don't know all of the answers. And then Kieran, Timberlake, as experts in, developing topical software or creating buildings or doing some topical research, you don't know all the answers either. So we've had to reach across the table and engage lots of, not only architects and engineers, but also people outside of those doors as well. And that's what's really, I think, making our partnership, our collaboration, even more powerful, I think, rather than me just doing it in a silo.
Cool. I'll ask one more question before we open up to the audience. There's this thread of research that was kind of amongst all of the talks. Does research start with a goal in mind? how do you folks, approach it? Is there a specific goal that you're trying to tackle, or is it something that, some other motivation that leads to it?
For us, it's a hybrid of sometimes yes, sometimes it's stumbling into a question as we're working on something else. And so if you look at it as the project initiated research, what are we discovering we don't know through the process of doing a project? That side of it probably accounts for, I would say, 70%, 70 to 80 of the types of applied research that we do. But then we try to carry an agenda of things that we're interested in that may not be appropriate for this project, but we put that on an agenda that can carry from year to year. And I'm always looking for what the project can give me, right? I had a conversation with someone at lunch and we were kind of talking about surfing and the idea that there's a give and take there. And I'm a lot smaller than the ocean. Sometimes a project's going to give me something that I may not expect, but if that corresponds to something in my agenda, let's jump on it, right? And if not, I'm not going to force that fit.
I think, as a consulting firm, like we have a lot of different disciplines represented, but I would say, ultimately it's working with, across discipline borders. Sorry, that's getting loud, but I think, because I was also trained as an architect, and like every studio project started with like really intense research on a topic. But where I'm at currently, I see like we don't really do that intensive research anymore. We rely on our relationships and our discussions with our collaborators, and we sort of trust that there's going to be this dialogue between us, and that interest can be shared across the table or through the project DNA. So we don't necessarily always get to get our hands dirty in really intense research, but we value that collaboration. It has to be there.
I mean, if we're talking about goals too, I mean, we're a very goal-driven firm. We've got a process for everything. We're ISO certified, but I still think there's definitely this acknowledgement that goals can change and can be informed by your research and findings. So I think, it's good to have that North Star, but it's also good to be nimble and to have some version of play within this. I think play, like when I think of computation, at least, one of the most attractive things in terms of computation is this aspect of play that it brought to architecture for me. So I think we definitely have goals. We definitely change them, just like our questions. And I think, we have questions and goals that allow for chance, happenstance, and for kind of changing a route. So when we evaluate new tools, we ask is it worth pursuing? And it's almost like we do fail fast sprints, right? So you can have goals, but they can be short, they can be scoped. Is it worth pursuing? And then once we get past that, it's is it possible? Like, can we do it? And then once we get to that, is it practical? So they're all questions. They're all kind of like, they have goals embedded in them, but they allow you to kind of stop quickly when the answer is no to the first one, but continue through and have some kind of structure at the same time.
Any questions from the audience? Yes, in the back. Microphone.
Thank you all for your presentation. The question I had is, the startup ecosystem in our industry is relatively young. You all presented softwares that you're building internally. Do you think about, as it matures, what that means for competition, or how are you going to market with some of the things you develop? I'm just curious your thoughts on that.
Well, I guess, okay, I'll start as someone who's worked for a firm that's put things to market. Yeah, so So Tally, the life cycle assessment software that I showed was a plugin for another commercial piece of software, Revit, and you can still buy it. Building Transparency owns it now. We gifted it to them, but originally when we started it, we sold that software commercially. So the large part of, if we're talking about open source or closed source, one of the largest pushes for a dollar value being on that software at the time was our data agreement too. So that data that we mentioned, that really valuable LCI data, it was valuable to us. Well, number one, because we didn't have it, but number two, also because we were doing a tool that was not supplanting, but providing designers an avenue to replicate to some extent expert specialist work, that we wanted kind of a degree of authenticity and trust. And so going to a data partner that was well known within the industry was also really valuable to us. And so Tally was a commercial piece of software, still is, you can still buy it. And then Roast is also a commercial piece of software. So those were both developed internally and commercially available.
At least not that I know of, we haven't taken something to market software, but we do have, like I mentioned in my presentation, a grassroots. Like it just started from structural engineers needed a way to quickly go from an architect's conceptual model into ETABS or Robot, which is a finite element analysis or structural analysis software suite. And it sort of grew from there. And this was maybe 6 or 7 years ago. And it was something that started internally, almost like secretive in a way, honestly, like a few people, 2 or 3 people kind of started it. And then it's grown into, now we have our core development team is about, 12 people right now. And we've open sourced that software and it's grown kind of exponentially since then, but we've open sourced it. We have 0 plans on monetizing it in the future. We kind of pride ourselves on sticking true to that grassroots mentality of like, oh, if there's something like, for example, building transparency EC3, like we have an adapter that I personally wrote that connects directly to their API and pulls in EPD data into, whatever UI you're looking for. But there's like a number of things that's just kind of like, oh, we have the framework, we gift the framework to the public. Don't expect anything in return. I don't even think we take any public data back in return other than download count. But yeah, no plans on marketing that. And I think that's not something that a lot of like smaller outfits can do. I don't think there's necessarily like, KT's not in the wrong for monetizing, a piece of software because they're, an order of magnitude of like 10 to 100, size differences is super important. It's critical to that. Whereas like we could actually afford to just like have some people go away and kind of disappear into our giant company and make something. But now we're kind of seeing the ramifications of that is that adoption is very difficult and, scalability is very difficult when, not a lot of people know about it or, it's not an official, monetized piece of software. So there are trade-offs to consider.
And I will add the environmental justice index or kind of framework that we showed. We're definitely, so it's a proof of concept, proof of method, really. So once we do have that, at least less larval, a little more fully fleshed, we are looking and keenly interested in making that open source. So it's not that our default is commercialization. It's just something we've done.
Thank you. That was very wonderful lectures. Thank you. I'm wondering, all of you are in the position for innovation or research, and do you see yourself in your own organization as a support person or a production person or a pursuit person? How would you interpret that? Thank you.
Yes to everything. I like the conversation about multiple hats that we had. Like sometimes I'm helping finish drawings and teaching at the same time. Like oh, this is how I would do it using computation, next time consider this. And then I can take away that principle to our core development team and we can flesh that out into real methods or a brand new toolkit or an adapter or something like that. That's then scalable. So yes to all of those things.
Yeah, the multiple hats thing is an interesting aspect of all of this. And, one of the hats that I think I wear often is a gardener, right? Safi Bakal in his book Loon Shots kind of talks about gardening really being how you go from idea to implementation, because you think about, and, in any successful business, they're going to have some things that have allowed them to be successful. And replicating those is a surefire way to continue to be successful financially. So when you have a new idea, it's very important that you protect it from getting squashed while it has time to gestate, to incubate. And so a lot of what you do as a gardener is protect something to let it sprout, to see if it has legs. And maybe you need to, call it off soon, within a couple of weeks, but that's a big piece of it. And I think one of the hats that you'll see many of us wearing at many different times.
Yeah, I mean, I would say the same thing. So even though we're internal and I have a lot of people and I have a title, it's similar to kind of what the discussion was before. We still go and work with others to figure things out. And we may have an idea, but we can't execute it. Or an idea comes from us talking to you guys, right? And we try to figure out things. So I think the many hat thing, it's just part of our nature. We've had that discussion internally. My team are all architects. We come from the industry. And so when we're asked to do something, it's very different than some others, because when we're asked to do something, we just go do it, right? So.
Thank you. Ladies and gentlemen, please join me in giving them a round of applause. Thank you.
Okay, thank you guys for holding out. We have one more sponsor break here by Orbital Stack. I'm just going to pull up their